Okay, so let P of H be the pressure in dynes per centimeter squared on a diver at a depth of h meters below the surface of the ocean. What do each of the quantities mean to the diver? Give units. Okay, so this one, notice that h is the input and h is meters below the surface. So this, when you plug in 100, this is going to be the output, which is the pressure. The pressure in dynes per square centimeter at 100 meters, at a depth of 100 meters. Okay. Now the next one, it says h such that P of h is equal to 1.2 times 10 to the 6. So 1.2 times 10 to the 6 is dynes per square centimeters. Now h, when you find h, so h is going to be the depth that you need to reach to reach a pressure of 1.2 times 10 to the 6 dynes per centimeter squared. Okay, I'm going to continue C down here. Now P of H plus 20. Now you got to be careful here. This 20 is being added to the entire function. So what this is saying is you're going to increase. If you're increasing to P, then you're increasing the pressure by that amount. So you're increasing the pressure by 20 dynes per square centimeter. Okay. Now this one, notice that you're adding it to the input. You're adding it to h. So here, P of h plus 20, this is an increase in depth. You're increasing the depth by how much? Well, by 20 meters, because that's how much you're adding. Okay, now on to the derivative interpretation. P prime of 100. This is going to be the rate of change, the instantaneous rate of change. Instantaneous rate of change at depth of 100 meters. Now, how do I know that it's depth of 100 meters and not pressure? Well, it's 100 is the input of the function, so it's also the input of the derivative. So this 100 represents the depth, just like these inputs represent the depth. Now, what are the units of that? Well, the units of that are dynes. So the units of pressure, dynes per square centimeter per meter of depth. So this is the rate. Those are the units of the rate. Okay. And then last but not least, for H, so H such that P prime of H is equal to 20. So it's the H is the depth, remember? So it's the depth in meters such that the rate in dynes per centimeter squared by per meter is 20 dynes per centimeter squared per meter. So how far down do you have to go for the rate to reach 20 dynes per centimeter squared per meter? That's what that's asking. Okay, so we've got a company's revenue from car sales, C. So car sales is C in thousands of dollars, is a function of advertising expenditure, A, in thousands of dollars. So C equals F of A. So here, notice, this is really important to keep track what the input and the output is. So the input, let me write it down. Okay, so the input, what you're plugging in, is advertising expenditures. So advertising and in thousands of dollars, and the output is revenue from car sales. So what it's saying basically is you spend a certain amount of money on advertising, and then the revenue goes up or down depending on how much you spend. So, just sort of thinking of it in real life, the more you advertise, the more sales you make, so the more money. But there comes a certain point where you over-advertise and you're spending more money on advertising than it's really worth. So that's basically the situation that we have here. So the first question says, what does the company hope is true about the sign of F prime? So F prime, or let's just write F prime of A. Okay, so to be able to answer that, let's just make sure we understand what this means. This is going to give me the rate of change and, instantaneous rate of change. But what really helps is writing down the units. So it's the units of this guy are the revenue. So dollars in revenue per dollars in advertising. So let's think about this a little bit. If F prime is positive, what that implies is that if advertising goes up, then revenue or car sales, let's put it, that's C. So car sales, also revenue from car sales goes up. Now if F prime is negative, what that means is that car sales are going down. So if advertising increases, then car sales go down. So I think it's pretty obvious which one you would pick, or the company hope, of course, would be this one, right? Because you would want that if you spend money on advertising, you would want your car sale revenue to also go up. So we hope that or the company hopes that it's positive. Okay, now B says, okay, what does the statement F prime of 100 mean in practical terms? Well, what this means is that, remember, at the instant that the input is 100, so here the input is advertising, and it's in thousands of dollars. So after you spend $100,000, you can word it a couple different ways. You can say that the rate of change of car sale revenue to advertising dollars is 2, or in this case $2,000, because that's what the units are. But I like to say it in a little bit more practical terms. What this means is that when you spend $100,000, the next $1,000, the next increase in advertising expenditure, so the next $1,000 spent on on advertising is going to that's going to increase the revenue by 2,000. So if you spend $1,000 on advertising, revenue from car sales will increase by $2,000. So that's what that means. So you can word it both ways. Either the rate of change, instantaneous rate of change is $2,000 at exactly this instant, or you can say if you spend another, if you increase this one by 1, in other words, if you spend $101,000, then you would get another 2,000 extra in revenue, which is obviously a good thing, right? Now, let's contrast that with f prime of 100 equals to 0.5. Now, here, if f prime of 100 equals to 0.5, you say, oh, well, that's okay because it's still positive, so it's increasing. But here, actually, this is not a good thing, because notice that what this is saying is exactly at the instant when you've spent $100,000. If you spend another, spend an extra $1,000. So if you increase this one by 1, your revenue, it's going up, but it's going up by 0.5, or in other words, $500. So here, you're negative, right? Because you spent 1,000, but you only got 500 out of it. So, being positive wasn't the only thing that we wanted. We want this guy to be over. We want our revenue to at least give us back our money that we got from advertising. Okay, now let's say that the company, for part C, plans to spend $100,000 in advertising. So if f prime of 100 is equal to 2, so we're in this situation, should the company spend more or less than 100,000 on advertising? Okay, so this is exactly what we were just talking about. So in this situation, we would say yes, definitely spend more, because you spend 1,000 and you get 2,000. But in this situation, you would say no, because you spend 1,000 and you get 500.